Okay, this is going to be a video on designing parts parametrically using equations, and you won't need SolidWorks or anything. But first, let's just look in SolidWorks to get an example of a part that we could even use this method for. So here's a sphere that has a spiral wrapped around it. This is made in a 3D sketch. We have it right here. And the curve is driven by equations, parametric equations, x, y, z, functions of t, ranging from 0 to pi, basically. And if you saw in there, 40 is the radius of the sphere, and 10 is it's kind of like the number of turns. And now we could use a method that we've used before, where we break this into a bunch of segments and then run the macro and get all those points. But if this is all we want to do and we don't want to attach like some other feature on here, like maybe a hook or something, then we can make this directly using Excel or something like Matlab or Python. So if we go over into Matlab, I have some parts prepared, and we can do that right now. So if we come in here into Matlab, I have defined a range of t, and for this first part we're going to have t set to 10 pi, which is 5 rotations, and we have 1,000 points, which is plenty. It's way more than you should need. And then I've defined some parameters for this first thing, which is going to be a helix. So my height 75. This is used to determine the height in z, and then my radius, which in this case is 30. It's actually, and then if we run this, I'm just going to run this selection here, section. Oh, something went wrong. Let's see. Oh, yep, okay. Okay. So I should have a height of 75, like I tried to design for, and my x is at 30. That's my radius. This is centered about 0, 0 in the y, xy. And so now I have these points in an array, x, y, z, and if I put those arrays, transpose them, and smush them together, and then write that to a CSV, I get the same format that we're used to. So I can come into the software here, go to import, find out where I saved that, and then open. And now we're seeing a little bit of lag because we have so many points. But once we calculate the bends, let's just select my material again. The software will loop through all those points, and it'll only display the points that are being used for the bends at our discrete length, which is determined by the pin location. And at this point, again, like you've probably seen in another video, got my G-code here. I can go up here and I can export Although I probably want to change to this orientation that has 0 collisions. And I can save that. And that's pretty much it. If we go back into Matlab, we can check out just a couple more examples. For example, here's the same part that we saw in SolidWorks, a spiral around a sphere. So the exact same dimensions and same equations. And if we run this selection, we can see the sphere here. Matlab does some weird scaling here. I'm sure we could define the limits and get it a little more to scale, but if we find this CSV and put it in the software, then it becomes more apparent that it is a sphere. And we could play around with this. We could stretch the Z and make it into like an oval. So let's say we wanted to do this, multiply that by 3 times, and then come into here and look at our, and now it's very elongated. So this method would be really useful if you're trying to make some math art, bend some cool shape, like this last one here. This is a spiral that has been wrapped around a torus. Let's have a look at the Matlab output really quick. And then let's open that in the software. And there we have our part. A part like this would probably fail because the length of the wire is so great that the weight of the already bent part starts to affect your rotations and you get slipping. Because just if we browse the G code here and look at one of the X commands towards the end, 3,499. So this is, to bend this part, you would need 3.5 meters of wire, which gets pretty heavy. But that's just a quick video on making parts using parametric equations. If you got creative with this method, you could combine functions. So I could make a helix, and then I could write another function that is centered about some point that I picked for the helix, and then I could merge those CSV files, just copy paste one at the end of the other, and I could build parts like that. But it's a much more abstract way of doing it than using CAD software like SolidWorks. Takes a lot of thinking. So that's it for this one.